Alright, hello everyone. Trust that you're all safe and that you're doing well. So we're going to use this first few weeks just to recap on what we've done in class up to before the lockdown. So we're going to start with again with the topsoil horizons. And obviously, if you were in class, you would know what we're talking about. But I'll go through it slowly, and if you listen to these videos or lectures, you should be able to know what to do in terms of classifying the soils. So just a reminder, and I think I'll post a video later, but the structure of the South African classification system, it consists of soil horizons, and those horizons makes up the soil form, and then that soil form can then be subdivided into soil families. So you'll have to have a new classification book. The old blue book is not going to work. You'll have to have a soil classification, a natural and anthropogenic system for South Africa. Alright. So yes, we're going to start with the topsoil horizons. It's always a good place to start, is from the top down. And in the classification system we've got six horizons, topsoil horizons. It's a peat horizon, organic horizon, humic horizon, vertic horizon, and melanic horizon, and then the last one is the orphic horizons. And in the classification there's a hierarchy. So you start at the peat horizon, and essentially it's a process of elimination. If you classify it as a peat horizon, then it is a peat horizon. But if it doesn't fit the criteria for the peat horizon, then you go to the next one, and the next one, until you find the appropriate horizon. Alright, so we are on page 39 in the soil classification book, and when you go to page 39, you will see that there's the peat horizon, and what you'll also see is that there's a general description of the peat horizon, but then there's also a diagnostic criteria, and that diagnostic criteria, that is the most important part of a classification, because before you can classify a horizon as a specific horizon, it has to adhere to that diagnostic criteria. So essentially you can change the diagnostic criteria into yes and no questions. So let's just look at the first one on page 39. It says that a peat horizon contains more than 20% organic carbon in environment associated with water inundation or at least water saturation for extended periods. So you can change that and say, do this horizon, does this horizon contain more than 20% organic carbon? Yes or no? If you answer yes, then you go to the next criteria, and then you can change it into yes and no questions. Let's quickly look at the first criteria, and I'm just going to find my pen here. What is important here is the 20%, and it's organic carbon. So soil, when you look at the soil analysis, it's not always presented as organic carbon. It might be that it is the organic matter content. So if you've got organic matter content, you have to organic matter, so that includes plant material and everything. It's not necessarily just carbon. If you've got organic matter, you have to divide it by 1.72 to get to an organic carbon content. So this is quite important. Okay, so the first criteria states that it should have more than 20% organic carbon, which is very, very high for South African conditions. Typically our topsoils have got an organic carbon content of less than 1%. So 20% organic carbon will only occur when you've got areas that are saturated for very long periods. So it should be inundated with water or saturated with water. For organic carbon content, that must be measured. But the second part of the criteria is that inundation and water saturation must be recognized by the physical presence of water or inferred through lowland terrain positions capable of accumulating and storing water or via wetland vegetation. So the key of a peat horizon is that it's in a wet area. You're not going to find a peat horizon in Bloemfontein. You're not going to find it on your TMU2 positions. You're going to find a peat horizon in a wetland, so saturated with water. And it's because of the saturation that the carbon accumulates. Saturated, no oxygen, carbon is not being broken down, and it simply accumulates. Alright, move to the now this is just a typical example of a peat horizon. You'll note the black colors where black colors are typical carbon gives off a black color. So this is a very light in terms of weight horizon, a lot of organic material. Very often they mine peat. If you go to a nursery or a builder's warehouse, you can buy peat. Most of that peat is actually from Germany, but it's something that you can add to your soil as a amendment. But under natural conditions, you're not allowed to plow that in South Africa. It's a wetland, must be protected. Black colors, water saturated. Good. The next horizon is an organic horizon, and the organic horizon is also similar to the peat horizon. Has got a high organic carbon content. So it's a surface horizon that has between 10 and 20% organic carbon. And again, I would like to emphasize that it's not organic matter, it's organic carbon. So typically in the next test, it's not going to be examined this year, 2020, but in the test, I will give you the organic matter contents, and you will have to convert that organic matter into organic carbon by dividing it by 1.72. Organic horizon is also in positions of saturation or subjected to saturation. So you either have to see some soil water in the surface horizons, or you have to see rusty root channels. The rusty root channels tells you that it's saturated with water for long periods, and when it dries out for short periods, air will first go into the root channels. Or it must be, in a terrain morphological unit which is capable of receiving water. So typically you'll find an organic horizon in a valley bottom. Not going to find it here against the slopes. You find it in an accumulating area where there might be some feedback from the groundwater or some lateral flows accumulating from upslope positions, but it accumulates over here, or it might be from the stream that accumulates in the valley bottom. But the most important thing, and probably the most defining criteria, is that the organic carbon content of more than 10%, between 10 and 20%. So just quickly back to what I said earlier, is that in South Africa, our topsoil horizons typically has a carbon content of less than 1%. So when you find these high organic carbon content horizons, like the organic horizon, like the peat horizon, it just tells you that there's something special about them. It's a specific environment, it's accumulating environment, it's waterlogged for long periods. It's not natural to find, or you don't find this often. Okay, so you're not going to find this in Bloem, typically not going to find it west of Bloem. You find these type of horizons, organic and peat horizon, in wetter areas, but also in wet landscape positions. Okay. So both the peat and the organic horizon are regarded as wetland soils. We are not allowed to plough wetland soils in South Africa, it's protected by law. Waterlogging is always going to be a problem. They might be fertile, but when you're going to plant them or plough them, you're going to disrupt the structure and you're going to get problems. You're going to get all the organic material will be then mineralized, and you're not going to have an organic or a peat horizon in 2-3 years time. So just leave them as they are. They've got a very specific role to fulfill in terms of acting as a wetland. Alright, next one is a vertic topsoil horizons. Vertic comes from the Latin, which means invert, to turn around. And the vertic horizon is a completely different horizon than the organic and the peat horizon. It's got a very strong structure and a high clay content. So I'm on page 41 in the classification book. And like I said, we're looking at the diagnostic criteria for now. You can read through the general description, you can read through the field identification, but the diagnostic criteria, that is the most important part of a classification. So the first thing about a vertic horizon is it must have a strong structure. So the structure cannot be moderate, it cannot be weak, it must be strong. And the second criteria is has to have more than 30% clay throughout the horizon. So those are two criteria that must be there. It must have a strong structure and it must have more than 30% clay. Then the next set of criteria is you only need one of the following. So you don't have to have slicken sides and cracks and all of these things. You just need one of them. You either need cracks of more than 10 millimeters or more, so large cracks on the surface, clearly visible, regularly occurring slicken sides. Remember from the morphology, the slicken sides are where the soil aggregates rub against one another. Or you should have wedge-shaped aggregates, self-mulching properties. We've got some rocks on the surface, or a plasticity index greater than 30. Again, I want to emphasize that for the vertic horizon, you only need one of these. You don't have to have all of them. You have to have a strong structure and you have to have more than 30% clay, but then one of the following 5. Then it will classify as a vertic horizon. And all these criteria basically says that the vertic horizon is physically active. It's moving. It's got a high clay content, it's got a strong structure, and it's shrinking and swelling. So that is a criteria of a vertic horizon. So when you look at this vertic horizon over here, you can see the slicken sides. You can see the structure, prominent structure, but important here is the slicken sides. And that is actually where the soils moved against one another. Again, strong structure, a well-developed structure, and typically got very clay contents. And this is also very characteristic of vertic horizon. When you walk on the surface and you see these large cracks on the surface, you should be you've got a good chance of being on a vertic horizon. And then of course, because it's moving, because it's shrinking and swelling, building on these type of soils are always a problem. When it's dry, they shrink, and when it's wet, they swell up, and you've got a moving foundation. So cracks in houses, cracking foundations, typically your building costs are 30% more when you're working on a vertical horizon. And in Bloemfontein, if you live in Universitas, Bloemfontein typically has got very nice vertical horizons. Yeah, if you go to the driving range on the way to Langhaven Park, that is also still on the university's grounds. It's also nice vertical horizons. Good. Okay. Okay. The next horizon, and I'm on page 42 now, is the melanic horizon. What is key about the melanic horizon is the dark colors. So it's got dark colors, and there's something that you have to highlight in your books is the dry state. So I'm going to give you, and when you classify the source, you're going to get a wet color and a dry color, but it has to have dark colors in the dry state. So that both the value and the chroma are 3 or less. Okay, but with the exclusion of 10YR3 over 3. So 10YR3 over 3, that is your color. It's not melanic, it's excluded. And then very important is that the red colors of use 5YR or redder are not permitted. So I've made this, maybe draw this graph somewhere, that you've got 5YR and then you've got 7.5 YR, and then you've got 10 YR, and then you've got 2.5 Y. On this side you've got 2.5 YR. Sorry, I'm drawing with a mouse, so it's a little bit difficult. And you've got 10 R, 7.5 R. Okay, so if you go from this side in this direction, it becomes more yellow, and in that direction it becomes more red. This is your hues. No? So when they talk about hues, the 5YR, 10YR, those are all your hues. So when we say that red colors of use 5YR or redder are not permitted, they mean anything in this direction is not included in the melanic horizon. Are you with me? I hope so. The next thing is that it should have 4 centimole exchangeable cations, which are calcium, magnesium, potassium, sodium, per kilogram clay for every 1% organic carbon. So you have to convert your carbon or your exchangeable cations you have to express it as a percentage organic carbon. So if I tell you that you've got 10 centimole C per kilogram clay, and I say that your carbon content is 3%, then you simply have to divide this by 3, that gives you 3.33, and then it is more than the required 4. So you have to express it per percentage organic carbon. Okay. If you've got any questions about this, let me know, but the important thing is I'm going to give you this. I'm going to give you the exchangeable cations per kilogram clay, and you need to convert that, or you have to express it per percentage organic carbon. Then it must have a moderate or stronger blocky structure. It does not have silicon size, and it's got less than 10% organic carbon. Good. So the key characteristics of a melanic topsoil horizon is the dark colors, or the dark colors, and then the cations. So the cations tell you the accumulation, the fact that it's more than 4 centimeters, tells you that this is an accumulating environment. So you get some clays and you get cations. It's not a freely drained, not a freely leached soil. Good. Here you can see the nice blocky structure, dark color. This is typical of a melanic horizon. So these horizons typically occur in arid and subhumid areas. In general, they are quite good horizons to work with. They don't have that shrinking and swelling ability of a vertical horizon. They're still fertile and they respond fairly well to irrigation. The second last horizon is the topsoil horizon, is the humid topsoil horizon. In this case, it also contains fairly high organic carbon content. Remember, we said that the average in South Africa is less than 1%. So if it contains more than 1.8%, it is relatively high. And as opposed to the melanic horizon, the humid horizon contains less than 4 centimole exchangeable cations expressed per percentage organic carbon. So this tells you that this is a freely drained horizon. And because these are base forming cations, calcium, magnesium, potassium and sodium are base forming cations, so when they accumulate in the soil, they tend to increase the pH. Soils become more alkaline. But when they are leached out, as in the case of a humid horizon, you expect acidic conditions. So when we are leached out, one expects that the rainfall should first of all be high, so the effectiveness of your rainfall must be high, and especially if you take this into consideration the organic carbon content as well. So in the humid horizons, you've got accumulation of organic matter, or organic carbon, together with freely drained conditions. So that tells you that there is very specific environmental conditions. Cool climate, a lot of rainfall, a lot of vegetative growth, and this gives rise to the formation of a humid horizon. The structure is massive or weaker than moderate. Now massive is not weak, it's just a massive structure is essentially structureless or apedal. So the structure of a humid is weaker than moderate in the dry state. So humid is not a strong structured horizon. And then the last criteria is that it does not overlie a horizon that is either an albic horizon or any horizon that has got grey colors. And we'll get to the grey colors. The grey colors are MB, just right or next to yours, defined for the albic horizon. We're going to get to the albic horizon, but you must write for the albic horizon, that is grey color, the spraying reduction or redox morphology. The redox morphology, or that mottling. You read redox morphology, it means you've got mottles, or pozzolic character. So essentially, this criteria just tells you that if you've got a humid horizon, water is not standing here. Let me just get a different pen. There's no water standing there. That's not a humid. A humid horizon is a freely drained horizon. Water comes in and it drains out, and taking with it the calcium, magnesium, potassium, and sodium. So it's a unique horizon. Typically, normally dark colors because of a high organic carbon content. You're only going to find humic horizons, like I said, in class on the mist belt. So wherever you've got high rainfall along the escarpment and mist cold conditions, that is where you can expect a humic horizon. Generally they are fertile, but they do occur in mountainous areas. So often they only used for grazing, and because they are acidic, when you do plant, something like aluminium toxicity or phosphorus fixation might be a problem, and liming might then be used to solve this problem. So yeah, very nice horizon, but it occurs typically in KZN, high-lying areas of the Eastern Cape, and it's not something that you can find in blue. Alright, the last topsoil horizon, this is where we're going to end the slide of this presentation, is the Orphic horizon. So only two criteria for that, and we're page 44. The first one, it occurs on the surface, and the second one, it does not qualify as peat, organic, vertic, melanic, or humic horizon. Okay, so just a quick recap. To help you, but we're going to go through a few examples hopefully in the near future. The peat and organic horizon, key criteria is for high organic carbon content. The vertic horizon is for strong structure and shrinking and swelling. Melanic horizon is for dark colors and cations more than 4 cm C. Humic horizon, fairly high organic carbon content, and it's leached, and then the Orphic is the remainder. Okay, just of Orphic. What is important about the Orphic and what is important about all the horizons is that we are looking at horizons individually now, but these horizons occur in a soil profile. So you can't say a horizon is good or bad, you have to consider the entire soil profile. So even though we said that humic horizons might be good for agricultural purposes, if there's a rock just directly below the humic horizon, then it's not good for agriculture. If you've got a deep subsoil, then it's good. So you have to consider the entire profile before you can make a recommendation or form your opinion about the agricultural potential of that horizon. Alright, I'm going to end there.